Okay, so I welcome you to this another session, afternoon session. Yeah, we'll continue with our TD1. We're doing exercise 4. We're doing exercise 4, so let us go to exercise 4. Exercise 4 says, déterminer les nombres réels alpha et bêta pour que les polynômes. Déterminer les nombres réels alpha et bêta pour que les polynômes pi égale x puissance 4 plus alpha x puissance 3 plus bêta x moins 1 de A admit une racine de 3. So we've already been told that first of all, the question says they want us to determine alpha and beta. They want us to determine this, and they've made our question to be very simple. They've said, and this is a polynomial which it admits in racine. We don't know the racine. We don't know the racine in racine d'ordre 3. So it agrees to a racine of order 3. This is what the question. So we're going to find this, and we're going to find its racines. So we're on A. On A. So alpha, beta appartiennent à R. As we've said, you know that alpha and beta are any real numbers. And then P, our polynomial is x to the power 4 plus alpha, x to the power 3 plus beta x moins P admet une racine de 3. This is what, so each information which are given on the question, understand it. Understand it, and each information is very important. And we're going to say A racine de 3 de P. We're going to name our racine A de 3 de P. What does it mean? When we say it's of order 3, what does it mean? Someone to answer it.
It means we moved 3 steps before we got 0 when dividing.
Okay. Any other? Thank you for that. Any other explanation? When you say we moved, because maybe we can give an example. It's my first time to attend an algebra session. So when you just say we moved, someone may ask you, what do you mean you moved 3 times? Did you move forward or backwards? What do you mean by moving? Use mathematical terms. The one who answered, what do you mean? If I may ask, moving.
Okay, what I mean is, the way we are moving, we are dividing. After dividing, we find the certain value. Again, we continue dividing the second time. Again, find the other value. Again, divide. So that's what I meant.
Okay. Okay. Thank you for that. I don't. Let me ask. Jabez, do you agree with that? Jabez, do you agree with what our friend has explained? I'm sure you are there and the network is very strong. Jabez.
I'm not sure about that. Yeah.
You're not sure.
Yeah.
We're from doing this. What does the person is saying we're dividing until we reach to the point. That's the movement he's talking about. But is it true? You're not sure.
Maybe I didn't get the question. What was the question?
The question is P admet une racine de 3. What does it mean that C admit une racine de 3? And then we say A racine de 3 de P. So what do you mean when we say P admits une racine de 3? Avec une racine which is A. We don't know the actual racine, but we we just conclude that our racing is R.
Oh, okay. So in this case, we'll get the one with, is it second oasis with the B, where there's alpha there, with the power, I mean the degree, I mean.
At what?
We'll get the degree of 3. Where there's 3, that is the lesson we're talking about, I'm sure.
So for you to go to the degree to order 3, what do you do? Changu,
Can I give it a go?
let us try Gale first. Changu.
All right.
Okay, so I think what happened was first we had the original equation where we replaced the racine, and towards the end of the equation we had 0. And then we differentiated it for the first time, it gave a 0. We differentiated for the second time, it gave a 0. But the third time we differentiated, we didn't get a 0. So we can say the order was 3 because 0 appeared thrice, or you can say because of the last differentiation, which was the third time. Something else.
Yeah, thank you very much. I'm sure it's the same explanation which the other guy wanted to give. And there's also Mr. Salosa P, who also gave the same explanation which you guys you are giving. I know the one who said we moved 3 times, he knew what he was talking about, but he never said we differentiated 3 times. Yeah, so I'm very happy that we're all moving at the same pace. So this is what I was explaining here down. This is what I was explaining here. What this means, it means that PR is equals to, we said R is our racing. So when we put our P when we put R into P, we are going to have 0. P prime R is going to give us 0. P prime R is going to give us 0, but P qua R is not going to be 0. This is what it means. P admit in racine d'ordre 3. So let us show this now. So we do our P prime is equals to 4x square. We drop this 4x square plus 3 alpha x 2 plus b plus beta. And then we go to P prime prime, we're going to have 12x x squared plus 6 alpha x. And then we say P3 is going to be 24x plus 6 alpha. Then honor, what do we have? So we have come up with the equation. So now let us put the racing. Let us put the racing. Mind you, our main aim here is to find here, we're finding this and this. So let us put our racing. So we say so what we're going to do here, we've put our P prime R is P prime R is equals to 0. This implies that we have 12. We're getting this right. We've got 12R squared plus 6 alpha R is equals to 0. Since we said this is equals to 0, so we equate this whole thing equals to 0. This is our equation, everything is equals to 0. And why we're using this equation is because we have no beta and want to know the racing which we're going to use. The beta is out because here, if we had 2 unknown, so it was very hard for us to know. It would have been very hard for us to know the value, the racing of when you have 2 unknown constants. So we're using this as a simpler one. So this is where we've put our R so that we can know the racing which we're going to use between the racings which we're going to find. So we have 12R squared plus 6 alpha R is equals to 0. What do we do? we factorize, we're going to have 6i is equals to 2r plus alpha, which is going to mean that our alpha, this will equate it to 0, so it just be the same. R, or not our alpha, our r is equals to 0, our racine may be equals to 0, and then we use this equation 2r plus alpha. It means the alpha will be this side to be negative. Then you divide with the 2, which means our I is going to be negative alpha over 2. So which one are we going to use? We've got 2 of them. So what we're going to do is, let us try to put them. Let us try to put them. Which one is going to give us which one is going to work? So we're going to our normal P, we try this racine. The 0, if it's going to give us 0. When we had to put it here to be 0, 0, 0, negative 1. And we said it's a racine, so it's supposed to give us 0, right? So when we said PR, which is 0, is supposed to give us 0. But what did it give us? It said it's supposed to be 0 is equals to negative 1. It has given us negative 1. Donc, impossible. It's not possible that 0 can be equal to negative 1. This is not possible. So, alors, this is not a racine of P. Alors, automatiquement, on va consider ça. This will be, we're going to consider this to be our what? Our racine. So our R is going to be equals to negative alpha over 2. So if that's it now, let us see. Yes, Kenneth K. Kulungu, you've got a question?
Before you go any further, how come you use the P prime to the 12x squared plus 6 alpha x? How come you didn't use the first one, which is 4x to the power 3, when finding the racine?
Yeah, thank you for the question. This is what I was explaining when I started. I said why we didn't use this or this one is because we've got 2 unknown constants, and our main aim is to just have one unknown constant in the equation. So to simplify our work, you can either use this or this, and we just, since they say if we can't use the first one, we try the second one again, we still have the unknown one. Then we go to the third one. When we went to the third one, we just had one unknown, which is the alpha. Alors, c'est la raison why we used this equation. Is it okay?
Okay, yes, I understand.
So we're going to use this now. So our main aim, we want to find this and this. And the other reason why we don't want to have a beta, we use an equation where we have no beta or both of them mean the same, because we'll come and, since this is a racine, we'll come and replace them here. And if again we have we'll make it more complicated now, because we'll have to multiply the beta with the alpha, because here we have maybe plus beta, shan, so it will be a complicated equation. So donc, our racine, we've known the equation of our racine is negative alpha over 2. Alors, what are we going to do? Okay. Are we using the values we are finding to? Are we using the values we are finding to prove the racines given in a equation? Yes. Well, yes. So when we find the value of alpha, we're going to put it there, and then we will know we're going to know our racine, the actual value of the racine. Thank you for the question, Salosa. Yeah. Okay. So first of all, what we're going to do, these two, we're going to solve for P prime is equals to negative. We're going to use this racine here, and our P, we're going to use this racine here. And we know that if it's a racine, it's supposed to be equals to 0. If it's a racine, it's supposed to be equals to 0. So we've got these equations. we have this equation. So we say P, we say this is our P, and then P negative alpha over 2 is equals to, when we put it here, since it will be a positive 4, so this whole thing will be positive, right? This whole thing will be positive, and this whole thing will be positive since we are putting it on x square, x to the power 4, so it's even. So this whole thing will be positive, and the 2 down, we power it to 4, so we're going to have 16. So I have alpha to the power 4 over 16. We come here, we come and put it in here. We're going to have alpha times z, since it's to the power 3, and this is negative, this is an odd number, the negative of this will be distributed here. So we're going to have negative alpha 4 alpha to the power 3 over, we power this to 3 to be 8, and then we come here, we come and put it, we're going to have this beta over 2, and then mwanza. And then we do for P prime also, for P prime, which is this equation, we replace with this racine, and which is supposed to be equal to 0. What are we going to have? We're going to have negative 4 times this to the power 3 over 8 plus 3 alpha 4, alpha squared over 4 plus beta is equals to what? To 0. So now we start playing with this equation, because we know they're all equated to 0. We're playing with them. Let us play with them. So we distribute this with this, we have Poisson's cut. So we've got when we multiply here, we're going to have Poisson's cut. So we've got this minus this minus this, or minus this is equals to 0. So we have this same thing here is equals to 0. And then also this other one again, we simplify the 4 with the 8. What are we going to have? We're going to have 1 over 2. 1 over 2. So have negative alpha to the power 3 over 2 plus 3 alpha to the power 3 over 4 plus beta is equals to 0 is equals to 0. And then from this equation, they've got the same Poissons, so we can simplify it. We can simplify it, and when you simplify it, our beta, when we simplify it, we're going to take it the other side. This is of the same Poisson, so we can simplify it. We put our 4 down here, we do the simple mathematics. Allow our beta will be equals to negative alpha 3 over 4. This is our beta, the equation of beta. And the mathematics which we did here is just this. 3 over 4 minus 1 over 2. We are just doing these constants, and then just come and add this. So it's just 3 over 4 minus 1 over 2 is 1 over 4. Yeah, it's supposed to be negative 1 over 4. So when you subtract this 2 to be 1 over 4, and then you take it to the other side, it's going to be negative 1 over 4 times this, negative 1 over 4 times the alpha to the power 3. So from here we found the value of beta. So if we found the value of beta, we go to our first equation where we had our beta. The first equation here, remember beta here, we'll come and replace our beta here with the value of beta, so that we have the same constant here. So what are we going to have? We're going to have, again here, we simplify this to it will have the same powers. When we simplified it here, when we multiplied it to have the same powers, so we can simplify this. When you simplify it, it's going to give us negative alpha 4 over 16 negative alpha 4 over 16 minus c. What are we going to have? This, which is alpha over 2, and then we've put the value of beta. We are putting the value of our beta here, which is being multiplied here. So it's this, and then we simplify this. Beta, we know that is equals to this. And here we even got our p-square, which is 24x plus 6 alpha. And then we go further. When we multiply here to have Poisson's 4, again we work out with this. We work out with this. We simplify it. When we add the 2, we're going to have alpha Poisson's 4 over 16, which is equals to 1. You multiply the 16 this side, and then you do you remove the 4, you remove the Poisson's 4, the Poisson's 4 allo. What are you going to have? You're going to have your alpha will be equals to 2, or your alpha will be equals to negative 2. You know that it's when you do your square root here, it's going to be, to cancel everything, it's going to be positive or negative. So it will be either be positive 2 or negative 2. And donc our beta, you just go to your equation for beta here. Just come and put your, when you put your negative here, going to have negative. When you put your negative, it will, when you put your positive 2 here, it's going to be 8, negative 8 over 4. When you cancel, it will be negative 2. When you go to your beta, to the other one again, what are you going to do when you put here to cancel? So it will be 2. So it will be 2 again, to be 8 over 4. So it will be 2. So these are the values which are going to have for alpha. Alpha to be either be 2 or negative 2, or beta to be either be negative 2 or 2. So in each case, so this will be going with this. This will be when you are making, when you want to put on the polynomial. This will go with this, and this will go with this. Yes. Jabez, you've got a question?
Yes, I have a question. On the differentiation of p of negative x over 2 is equal to x to the power 4 over 16 minus 6 x to the power 3 over 8. Yeah, why when differentiating it, why are we changing the signs?
When differentiating it, we are changing the signs.
Yeah, yes. For example, there we have x to the power 4 over 6.
Where have we changed the signs?
There, in the normal equation where there's p.
These are the differentiations which we had. So you are saying here.
Yeah, yes.
You are saying
where there's, for example, there's x to the power 4 over 16. When differentiating there, so put negative 4.
No, I'm getting from the differentiated one already, Jabez. I've already differentiated them. So I'm saying P of negative, just the P of negative alpha over 2. I come and replace my negative alpha over 2 into this P. I go to my P prime, the equation for P prime is equals to what? It's equals to 4x3 whatever. I come and replace with negative alpha over 2. This is where it will be negative 4 because we have a 4 here. Then this over this. Is it okay, Jabez?
Oh, yeah, it's okay, it's okay.
Yeah.
Thank you.
You don't differentiate it inside there now.
I have a question.
Yes,
when we're solving for the beta, there where it is equal to negative alpha cubed over 4. Yes. Now that other equation that's at your right hand side, 3 over 4 minus half is equal to quarter. I think I didn't get where that whole equation came from.
Where?
There where it says There where it's 3/4 minus half is equal to quarter. Yes, I think I didn't get where that equation came from.
This one, no. I was just showing you this one. I was just showing you that as I was working, it's this. This is -1/2 is the -1/2. I'm just getting the constants and I work with them, and then I just come and these they do not change when you are working with, when you're adding the Poissons, these they do not change, they just remain the same. So I just got the constants and worked with them. And then I just come and introduce this. Indices. Are we okay there?
Yes, I'm okay.
Yeah.
Then can you also repeat the down part of how you found the alpha?
Okay. Are you Kennedy? Is this Kennedy?
No. This is Ashen.
Okay. Kennedy is I think is asking the same question down, which you are saying I should explain. What assumptions are you using to find beta and alpha? They are not assumptions. Is it simultaneous equation or not? I'm not even using simultaneous equation. This is just a simple mathematics. I'm not using simultaneous equations, because if I was using simultaneous equations, you would have seen. So here, what we are using, here we're just using this same equation. So that's why this was very important. The order 3, you come up with the equations. When you come up with the equations, what is our question? Our question says, they want us to identify this, the value of this and this. So what are we going to do when we've been given this hint of order 3? What are we going to do? And we know that R is a racine to order 3 de P. R is any racine. So first of all, let us find what our R is. So for us to find what our R is, let us use an equation which has one constant. And this is the equation here. So we didn't use this because we had these two, it would have been very complicated. We come to this one again, we can't use it. So we go to P prime, which just has the alpha. And then what do? We know that this is equals to 0. And why again we didn't use the P to the P is because this was not equals to 0. The P was not equals to 0. And we don't know, so it would have been very difficult to equate it. So the only possible equation you can use is this. You can't use this because this is not equals to 0, but this is equals to 0. So it is easy for you to find your R. So what are you going to do here? We come here. We say our P of R, which is equals to 0, where there are X, we put our R, and then we factorize it. We're going to have 6i is equals to 2r plus C, alpha, which is equals to 0. And if it's equals to 0, we have two equations. We've got this is equals to 0, and this equation is equals to 0. So 6i is equals to 0 is just the same as I is equals to 0. 2r plus alpha is equals to 0. The alpha will go this side, we have negative alpha. Then you have 2r is equals to negative alpha. You divide with the 2 here, and then here with the 2. So it will be r is equals to negative alpha over 2. And then let us see, try in our P0 if this is a racine and this is a racine. So we tried this, it gave us to be 0 is equals to -1, which is impossible. So 0 here is not a racine of P. And then automatiquement, donc R is equals to negative alpha over 2. This is our racine. So if we found our racine, then let us get any equations from above so that we work out with them. And we can get the first equation, which has the beta. The first equation, this one which has both, and the second which has beta. So we said, okay, let us work with these which are equal to 0. P prime and P. and we put its racine, which is, and a racine means it's equated to 0. So we come and replace it now in P. We're going to have this is equals to what? To 0. In P prime, we're going to have this, which is equals to 0. Let us simplify it. This can multiply with this. We have to the power 4, and the rest you just come and put them the way they are is equals to 0. We simplify this 2 here 8 with 1, so it will be negative 1 over 2 plus these. We simplify them, we multiply this with this, it will be resource square. Yeah, we have is equals to what? Is equals to 0. And then from here, since these are of the same resource, then you can find the equation of beta, because you just have beta here. Allow beta is equals to this equation, because you just add this to this plus this, and this is what I showed you outside here. Just 3 over 4 minus 1 over 2, which is equals to 1 over 4. And then just take it the other side to be negative. So to be negative lambda square over 4. Are we okay? Jusqu'à ici.
Oui, c'est clair.
Yeah, it's clear.
Can you explain again on the B?
On the what? Kennedy, you are the one who is asking.
No, it's me.
Me, David.
Yeah.
Okay.
Yeah, like the way you concluded that B is equals to neg alpha to the power 3 over 4.
Mm-hmm. So yes, sorry, I didn't get your question. You are saying you want me to which part?
Yeah, just explain again how you concluded that B is equals to neg alpha to the power 3 over 4.
Yeah, okay. Let me do it. Kennedy, let me just answer this and then you come in with your question. So we've got so it's just the mathematics here. Indices, numbers of the same powers, they do what? They can add or subtract for addition and subtraction. So these, they've got the same powers, this to the power 3 and this to the power 3. What do you do? Just work out the constants, because these, they do not change. Indices, when adding or subtracting, the powers do not change. So I just got the constant, I worked out the constants, and then after I found 1 over 4, then I multiplied the 1 over 4 with the alpha to the power 3. So here I had the alpha to the power 3 over 4. And then I take it the other side, it was negative alpha to the power 3 over 4. Is it okay, David?
Yeah, it's fine.
Okay. Okay, FD, okay, it's just okay. Where did for Kenneth, the question is, where did the 4 alpha over 8 come from? I thought
bosses, I've already understood.
Oh,
There's only, it was sent a long time ago. The only place where I'm confused is there where you were saying that P0 is equals to negative 1. Was it an assumption, or maybe you solved it somewhere? It's not sitting well. Where did it come from, the negative 1? Everywhere else I'm clear. It's just here.
Here.
Can I come in, sir?
Yes, you can come in, please. You can come in.
Where you got this negative alpha power 3 over 2? Right?
Kennedy, you have been asked a question.
Kennedy?
He's saying where there is negative P0 goes to negative 1. Where it's saying impossible.
Yeah.
Here.
Yes, there.
Why it's impossible?
Where the negative 1 is coming from? Did you solve it, or maybe it's an assumption?
I solved it. We're
Using
saying
which equation?
P of 0. Go back to your P of 0. This is our P of 0. we put our P of 0, we're going to have 0 here, 0 here, 0 here, minus 1. And our P, we said it's a racine, so if it's a racine, it's 0 is equals to negative 1. Kennedy, are we okay?
Okay, yes, okay.
And why we're saying is impossible is 0 equals to negative 1.
No, it's not.
It's not, yeah. So that's why, and then we conclude that we're going to use this other racine. Everyone is okay up to this point. Okay. Okay, that's good.
Can you kindly explain again, starting from P3 prime?
Where?
Just after you concluded that B is equals to alpha to the power negative 3 over 4.
Yeah, I'm finishing here.
All
We're
right.
here, right? Yeah.
Yeah.
Yeah. So we have so we've got our P square is equals to 24x plus 6 alpha. We just got the same equation which we have there on top. Then we continue with our normal calculations. So since our beta is equals to this, right? Our beta is equals to this. We go back to this equation. We have beta here, so we can come and replace here. And these are of the same power, so you can simplify this. And when you simplify this, it's going to give us negative alpha to the power 4 over 16. This is what this is going to give us. You can use your calculator, it's going to give you that. And then if it's going to give us that, well, then we can write it in this form, and then which means this will be 1, and then this will be one thing. Then we've got negative alpha beta over 2 minus 1 is equals to 0. We put where there's beta here, we come and multiply with its value, which is negative alpha to the power 3 over 4. And then our 1, this is negative 1, goes the other side. So we just take it to because it's only constant. So we take it the other side. So is equals to 1. We multiply it, and we know here I was just writing our beta is equals to this, so that we know where we've put it here. And then we multiply these to have Poisson's 4. When we multiply this, we're going to have 8 here to be positive, so it will be this plus this of the same powers. So if they're of the same powers, you can work out this is going to give you a positive alpha to the power 4 over 16 is equals to 1. Then you multiply it the other side here, you're going to have this over 16, and you know that you can use now a square root. You square it, knowing that your answer, when you use the square, it will be, your answer will be plus or negative. You know that. It's like you're finding this discriminant. After you found this discriminant, now you know your answer is either positive or negative. So positive or negative with your square root. When you square it the first time, it's going to give you what? It's going to give you 4, and then again 4, you do it again, it's going to give you 2. So since it's negative or positive, so it will be alpha is equals to positive 2, or alpha is equals to negative 2. A donk beta, you just go to your equation now. You come and put if your alpha is 2, then your beta will be equals to what? You put your negative here, you put your 2 here to be negative 8 over 4. When it 4 into negative 8 to be negative 2, and when your alpha is equals to negative 2, and you come and put it here to be plus 8 over 4 into 8 to be 2, beta equals to 2. So you are going to have two kinds of equations where alpha is equals to 2 and beta is equals to negative 2, and where alpha is equals to negative 2 and beta is equals to 2. Are we okay here?
No.
Where?
I think I'm a little bit lost on the calculation. The way you have, I think this is alpha to the power 4 over 16 minus alpha to the power 4 over 8 minus alpha beta over 2 minus 1 equals 0. But on your other part, I know alpha is equal to, I don't, what is the value? Eh?
Yeah.
Have you?
No, no,
No,
beta.
that's beta, yes.
Yeah.
Then alpha, we didn't find alpha, did we?
Our alpha is what we're finding here.
Oh, okay.
Alpha.
I was wondering where the over 2 went, but it's okay. It's okay. Yeah.
Okay. Thank you. The other one, any other questions? Are we okay? Kennedy, I don't know if you are agreeing that it's okay or you are raising your hand.
It's a question.
Yes.
I've remained a bit behind. Why did we equate it to 1?
Why did you get it to 1?
Yes, there.
This is our equation here. We've got a negative 1. This is a constant. It goes the other side. All these they've got alpha, alpha, alpha. This is a constant. So you take it the other side. It will be positive. Are we okay? Kennedy. Is Kennedy
the network was bad. The network was bad. I didn't get your explanation.
I'm saying this is our equation which we're working with. These are of the same powers. When we simplified them, it gave us negative alpha 4 over 16. Right? When we simplified them, and then when we put our beta here, it gave us this. And then here we're supposed to have negative 1, but it's just the same if we write it in this form. The negative 1 goes the other side to be positive 1. This is how it was equated to 1. The network again. Kennedy.
Now, when you equate it to 1, does it change the meaning of the equation?
No. It's the same thing. How does it change the meaning? Kennedy.
Since when you equate it to 1, the only way the alpha will be found is because something has been equated to something else.
Yeah, it was equated to 0, right?
Yes.
Our equation is equated to 0. And then it's because 0 is nothing. You can just take this and it's a constant. So these are like terms, they are constants. So this is like we're taking into its like term. Then you add now 0 plus 1, it will be 1. Kennedy, can I do a kina 40?
Okay, good.
Okay. Olivia, I don't know, Olivia has a question. You can go ahead, and then the other one wanted to speak. I don't know if it's the same. Is Olivia wanted to say?
Yes.
Yes.
I'm not quite clear with which equation you used in finding the beta.
Oh, this one. We have two equations. We've got the P prime and the P. The P prime is the one which has the beta on its own. And as you be working them, it will simplify it itself. So I simplified this. What did I do? I multiplied this with this. It gave me what? 3 alpha 3 over 4. I simplified it to be 1, to be 2 here, to be negative. This 3 over 2 plus beta, this beta which we have here is equals to 0. And then these are of the same power, so you can simplify them in this form. 3 over 4 minus 1 over 2 is equals to 1, or is equals to 1 over 4. Is equals to 1 over 4. Is equals to 1 over 4. So here, what are we going to have here? We're going to have alpha 2 over 4 plus beta. to be, when we do the mathematics here, it will be alpha. When you do our mathematics here, to be alpha over 4 plus beta, and then you take it the other side. Since you want to make beta the subject of the formula, when it goes the other side, what are you going to have? Negative alpha 3 over 4. Are we okay, Olivia?
Yes.
It's fine?
Yes. I also want to ask, which did you use in finding the value of alpha?
Which what?
Which equation did you use to substitute in order to find the value of alpha?
I used the first equation now because why I never found either alpha or beta here is because I didn't know the value of one of them. At least if I know the value of one of them, I'll be working with one unknown value which I can work out easily. So that's why I went to the second equation and I saw that here it's possible for me to find the value of beta, or to make beta the beta in function of the other, beta into the function of the other. So this is what I did. I went to this equation, I made it, and then I made beta into the function of the other. Then I went back where there's beta, I came to do what? To replace here. So on our equation, these are of the same powers. So this minus this, it gave us negative alpha 4 over 16, then minus alpha over 2, and then inside D, we put our beta here. This we multiply with our beta, which is this. So we multiply with our beta, we expand this. When we expand it, what are we going to have? We're going to have this, it will remain itself plus C. When you expand it to be plus C, alpha 4 over 8 is equals to 1. And our 1 is from this equation I've just taken the other side, is equals to 1. And then these are the same power, you work them out. You're going to have alpha 4 over 16 is equals to 1. Donc your alpha 4 is equals to 16. Then you simplify it. Your answer, since you're using a square root, to plus or negative. So alpha is equals to 2, or alpha is equals to negative 2, and donc beta is equals to negative 2. Why our beta is equals to negative 2, and our alpha is equals to 2. We go to the equation, the beta. When we go to equation beta here, what are we going to do here? We put our 2 here to be negative 8 over 4, which will give us negative 2. When we put our negative 2 here, to be 8 over 4, which will give us 2. So we're going to have, on our equations on P, when we replace our alpha, we're going to have two different equations. One equation where when alpha is equals to 2, our beta will be equals to negative 2. And the other equation of P will be when alpha is equals to negative 2, beta will be equals to 2. Are we okay?
Thank you.
You're welcome. There's another guy wanted to ask a question. You can come in, or it's been answered.
No. I wanted to ask that when you find the values of beta and alpha, do you replace them in the original equation, or when you solve that too?
Okay, that's the second question which we'll be having now. Thank you very much for that question. Any other questions? Are we all moving together? Guys, we need to be asking questions. If you're not clear, David.
Yeah. Like
Yes.
What was the purpose of writing the equation P3 is equals to 24x plus 6 alpha?
Addition. What's the what?
What was the purpose of writing the equation P3 is equal to 24x plus 6 alpha?
I don't know your network, bosses. David, your network is there? Are you close to anyone? I'm failing to get you can put the mic or the phone closer. You're too low.
Yeah, I was asking that what was the purpose of writing the equation of P3?
Oh, the equation of P3. It was we just why we wrote it. As I was distributing the equations which we have, I just wrote it I was checking if I can get something from it to solve the equations, but I saw no, it couldn't work, and it wasn't even equated to 0. Donc, that's why I just left it there. It was sort of an error. Are we okay, David?
He said that is okay.
Okay, thank you. Any other questions before we proceed? Any other questions? Okay, thank you very much. I'm very happy that we're moving together. Our bus is full. Everyone is in the bus. Yeah, so we can go to B. Calculer cette racine et donner la décomposition de P en facteur réductible. Calculer cette racine. So they want us to find the racine A and then donner la décomposition de P en facteur réductible R. So we have to decompose it in R, and we find the racine of the racines of P. So we go to our B. So our B says P is equals to x to the power 4 plus. This is our P, right? P is equals to x to the power 4 plus alpha x3 plus beta x minus 1. Donc, we're going to have two equations. We said when our alpha is equals to 2, our beta will be equals to -2. So our first will be x to the power 4 plus 2x to the power 3 minus 2x minus 1, or our other polynomial which we're going to have is p is equals to x to the power 4 minus 2x3 plus 2x minus 1. And then what will be our racine d'ordre 3? What will be our racines? Our racines I will be equals to -1 and I will be equals to 2, because the equation of the racine is equals to what? What's the equation of the racine? Gibson? Are you there, Gibson? What's the equation of the racine which we found? Hello? Anyone to help us? The equation?
Will it be negative? What's that symbol? Alpha to the power 3 over 2. Am I right? I don't know if it's the power 3. I can't remember, but
you're almost there, but it never had the power. Our R was equals to this, our racine. Yeah, it was I is equals to negative alpha over 2. And over 2, and then here how many racines are we going to have? Because we know that our alpha is either 2 or -2. So when our alpha is equals to 2, our racine will be equals to what? -1. When our alpha is equals to -2, our racine will be equals to what? To 1. This is what we did here. So the racines to R will be equals to -1 or R will be equals to 1. Are we okay with the racine? And the racine is of order 3. Are we okay?
yes.
Yeah, so we just want to prove if it's true. So we can just use P3 if it will not give us 0. since you can use any to prove. When you come and put here -1, what are you going to have here?
-24.
-24. And then here, if this is 2, if this is, because when you use -1, then we have 2 here, right? Then
Yes.
our alpha, yeah, so it will be -24 plus 12, which will give us what? -12, which is not equals to 0, right?
Yes.
Yeah, although we've proven that this is racine, and if you want, you can also try for this here, it will not agree. Although, dans les deux cas, we have 2 cases. We have 2 cases where our racine is equals to -1 and where our racine is equals to 1. So we have to decompose it. So since they've already told us it's of order 3, so it means our equation to be P is equals to, when this will be our equation of the racines, right? This will be the equation of the racine, and our racine is n, so we'll be putting here n. And we know that this is power 3, right? It's ordered 3, so it's of power 3. Its racine it will have of power 3, and then the total number of what is 4 of P. So which means your Q will be what? Of degree 1, right? The degree of Q to be 1, so to be x plus alpha here. Alpha is not the same alpha which we have in here. No, this is just alpha to mean any constant. So KUA, so the first case where R is equals to -1, our P of x will be equals to what? We have our P of x where if it's equals to -1, then this is the equation which we have. Our alpha, it will be positive here, and our beta will be negative here. So we're using this equation. And then we know this it is of power 4. So it's the quotient to be equals to this equation. This equation. So we have x plus 1 to the power 3 alpha x plus omega. So we have degree de P is equals to degree de P is 4, and here the degree of this polynomial is 3. Here to be plus, right? You know the negative to be plus, so it's 3 plus degree de Q1, which will be 1. Hello, from this, what are we going to have? We just have 2 of them. So you just get the coefficient, the first one for this one, the one for the degree is the one which you're going to have here, which is equals to 1, and the degree for the last one, which is the constant, which is -1. Allow your P, where in the case where I is equals to -1, is going to be decomposed in this form. C'est la decomposition de P, this Px da R. But you can do it in C, you can simplify it further into C here. You know this. This to the, in C it will, no, in C it will just be the same, because you have 1 here, 1. So it's already simplified in R and in C. So in R, it is just this decomposition, and here when you multiply here, you're going to have 4. So the degree here is the same as the degree here. Are we okay here? The first case. If we're okay,
No,
can raise our hand.
no.
Where
Can
are
you
you problems? So where
On the decomposition part, just the beginning of the decomposition, I think that's where I'm getting a bit lost.
here,
Yes.
so we're saying usually how do you write the equation of a racine is x minus r, where our r can be any racine, right? The one who's asking a question?
Yes.
Yeah. So if it's like that, then our equation, which and is ordered qua. We said is ordered qua. So we're going to have our equation to be p is equals to x minus r qua 4x plus alpha. And then r is equals to -1. In a case where r is equals to -1, if our racine is equals to -1, then what would be the equation of our p of x? We know that our p of x, it will mean that our alpha is equals to 2 here and our beta is equals to -2. So we're using this equation. Although we're going to write p is equals to x plus 1. The negative, when you put it in here, to be plus 1, 3 for q1. And then we know that this is of degree 4. And here we've got of degree 3 plus degree the q1. And here the degree here must be equal to the degree here. So if here the degree is 4, then here we've got 3. And the degree of this will be what? It will be 4 minus 3, which will be 1. Donc, degree the q1 is equals to 1. And then from there, this is the equation. I'm going to have x plus 1 puissance 3, then alpha x plus omega. We close here. And then we just get the values of these. We just have 2 of them. And this is the C. When we just have 2 with degree 1, just know that you get the coefficient from the normal equation, the coefficient here of the one with the degree and the coefficient of a constant. So the coefficient of this is equals to 1, so which means this will be equals to 1. Our alpha here. Alpha is not the same alpha which we've been using. This is just where we've just stated this. Say meaning alpha can be any and the omega can be any real number. So we've solved that alpha is equals to 1 and our omega will be equals to -1. So we just come and put them in the equation. P is equals to x plus 1 to the power 3, x minus 1. Alors, c'est la décomposition de P of x dans R.
How is omega -1?
Omega is -1 from the equation here. The coefficient here is equals to 1. We're saying our equation, for the coefficient for the one with the degree, because this is the one which is going to give you the degree of the polynôme. You get it from the coefficient of the degree of the normal polynôme, which its coefficient is 1 here. So which means the coefficient of this will be what? 1. Then you go to the other one here. This is a constant. The coefficient of a constant is -1. Alors, here again, this is a constant. So which means the coefficient of this would be -1. Alors, this is just equals to -1. So if you want, you can divide this into P. You distribute this and then divide into P. You're going to find this, but it will be too long for you. So it's better. This kind of equation is a simple way. You not panic. You not waste your time in the exam. Just understand it. So I don't know if you've understood.
Yes.
Okay. Are you
Wait,
sure? Okay, you can go ahead.
One more part. I just want the clarity.
Yeah.
When we're doing the decomposition, I understand the part where you say x minus a to the power 3 or whichever order. Then the multiplication on the other side, like that's the original equation. That's how it's supposed to be done at all times. I was just wondering where that part came from. Yeah.
Which part?
The x plus alpha. Is that how the equation? Is that how it's always supposed to be?
It's the degrees. This is what I was explaining. I said the degree on the left must be the same with the degree on the right. You are decomposing P. You are not changing P, because if the degree this side will be less than the degree which for P, then you have changed the equation and the answer is wrong. So what are we doing?
There. Where there's done the Dukas, just after that equation, the P is equals to x minus a to the power 3 power x plus alpha. I wanted to just ask about the x plus alpha part. So is it always supposed to be there? Like what's
x plus alpha?
Yes.
No, it's the same thing which I'm explaining here. It's the same. This is the same equation which you have here. This is the same. It's of degree 1. So it's the same thing which I'm explaining here. On how
Okay,
we
no,
come up with.
I understand the down part. I just wanted to ask, but I do understand what you've done on the part going down. I just wanted to ask.
Oh,
Yeah.
okay, no problem. It's just the same thing. It's just the same thing. Now, I was just indicating it in a normal form of saying, since it will have of degree 1, so this is how it will be written in its form with our R, without us knowing the R. And then when we put our R, this is where this whole thing comes about. All right. Any other question? Any other question? Yes, Maria. I don't know if it's Miriam or Maria. Yeah, you for the you get the coefficient, and the coefficient is just the same as you are just getting the constant there. Or if you want, you can use the equation which are if you want, you can use the equation which I showed on the first 2 questions which we did. Yeah, but always the first and the last you get from the polynomial. Where are you getting the degree 1 from? Can anyone explain this? Where are you getting the degree 1? We did, this is the same thing that we did in the past question. You all said you understood how we found, we had 2 equations, how we came up with the equations. Anyone to help us with this? Why are we having Q to be of degree 1?
Why we're having Q to be to the degree 1, that is because we want it to have this, we want it to have the same kind of degree if we multiply as the one in P of X, which is equal to X power 4, because 4 is the highest degree. So we want that if we multiply that X times the one that is enclosed in the X plus 1 the power 3, we want it also to have the highest degree, which is to the power 4.
All right. Yeah, David, is it okay? Okay. All right. Thank you very much for the one who has explained.
Yeah.
So we go to case 2. It's just the same thing.
Excuse
Yeah, there's someone with a question. Yeah.
Yes. On P prime, the third differential of the original equation, we found 24x plus 6 alpha. Then
Yes,
we are replacing alpha x with the -1. What were we trying to find?
We are trying to we are proving that -1 and 1 the racines of P.
Okay. Thanks.
Yeah, so when we use this, you see here, when we used this, we just used one of it to just say, if for P3 it will not be equals to 0, then it is agreeing with everything, because we said on when we differentiated the third time, it never gave us to be 0. That's what we're just proving there. Are we okay?
Yeah.
Any other question before we move to the last part? All right, we go to the last part. We go to the last part. So Wonka the other car where r is equals to 1, then our p of x, if it's equals to 1, we know that here it will be negative 2x, here to be our alpha will be negative 2, and our beta will be 2. So this is the equation that we're going to prove from. So which means our p will be equals to x minus c. Since here is 1, so it will just be minus this to the power 3. This plus this is equals to, this is equals to q1. Degree the p is equals to 4. So it's just the same thing. 3 plus degree this, which will be equals to 1. Just go to this, you get this is equals to 1. So this will be equals to 1. We get this, which is negative 1. It will stand for the constant here, which will be equals to negative 1. Negative 1. Then you come and put it here. That will be your answer. C'est la décomposition de Px dans R. What would be, can someone tell us the value of this in the decomposition of P in C? How is it going to be? Someone to help us the decomposition of this in C. Someone to help us? Katongo, who is Katongo? How are we going to decompose this? Can you help us? In C, if you've understood your cool, you guys, how are we going to decompose this? Because these are the same questions I'll give you in the assignment. The same questions. It will be more in C. How are we going to do it? Mario Baroted. How are we going to decompose this in C? Mario. Simon. Anyone to help us, guys? Anyone to help us? In case they said, these questions they ask, in case they tell you, you decompose now this into in C. Simon.
I think maybe that x minus open bracket x minus 1 close bracket cubed is going to be split. We're going to have x minus open brackets x minus 1 close brackets. Then we have x minus 1 close bracket squared. Then that x minus 1 squared, we know we can also expand it.
How?
In this situation, which is we're going to have x minus 1, that will be the first part. Then the second part, we're going to have that will be x squared. That will be x squared minus x plus 1. Sure. Then the third part, we're going to have x minus 1.
Oh. We'll keep your answer. Anyone else to help us here?
Okay.
We'll keep that answer, and then we'll verify at the end. This is very important. Someone else, if they tell you you decompose this.
The decomposition of P in both R and C it will just be x minus 1. Those three roots should be written on their own, together with the last root, which is x minus 1, without introducing anything, because x has the highest power as 1. That's all.
Okay, who is speaking?
Kaweza.
Eh?
Kaweza.
Kaweza, okay. We'll keep that answer. We'll keep any other explanation. We'll keep that answer and the explanation. Any other explanation? Changu, is it true what the other two guys have explained? What do you think? How are we going to decompose it into C?
I'm not sure.
Okay. Which other person? Any other
I've got the
person to
question.
help us? First, we'll answer the question after you answer my question. I'll answer your question. It's concerning the same week?
Yes, it's concerning the same. Is it
Okay, so
in form of I or J?
no, it's you now to identify that, because the questions which will be given, you have to know this identity is for J, this identity is for this, or this is this. And you need to know the rules. You need to know if it's reduced in C, how is it supposed to be? In R, how is it supposed to be? This is very important. Nathan,
I think I can give it a try again.
who is that?
The same one who had given the first answer.
You've changed your mind.
Yes.
Okay, go ahead.
If we split that x minus 1 in x minus 1 to the power 3 into 3 parts, we're going to the first part we're going to have a difference of 2 squares, and the other part we're also going to have a difference of 2 squares. That is including the other one, which is x minus 1 over there. So if we expand the whole of them, that means we're going to have open brackets x plus I, close brackets, open brackets x minus I, close brackets, open brackets x plus I, close brackets, and the other one, which is the last one, which is open brackets x minus I, close brackets.
So we're going to use I as our racing. No,
Yeah.
because when you say something, whether it's wrong or right, just stand for it. Just stand for it. Okay. So you
This
said
situation, I'll go with I.
you go with I. Okay, we like that thinking. Like that thinking. Any other person? Any other person? Just trying. No one is giving wrong answers here. They are all correct in their own way. They are correct in their own way. So just try. Any other person from the girls? What do you mean? It's just the same process, right? Mr. Salosa, you have the mic there to explain what you mean. Any girl or boy who wants to come in? Wants to come in? Messi, what do you think? How can we decompose that into C?
I think we're going to expand.
So yeah, so how are we going to expand it? We're
Okay,
going
so
to
there,
multiply.
yes, we have there where we have x minus 1 to the power 3. That will give us x minus 1, x minus 1 again, x minus 1. So those will be 3. And then we have x minus 1, the other one, which will give us 4 of them. So we'll expand, then it will give us x to the power 4 minus 4x to the power 3 plus 9 to the power 9x to the power 2 minus 4x plus 1.
Aren't you going back?
I do not know.
You have to decode because it's supposed to be, it's in its reduced form. Decomposing it. Yeah, so we also consider that to be, we also consider the answer. Thanks for trying. Any other person? Any other person?
I've got, I want to try as well.
Who is this?
Ted.
Ted, you had given which one?
Yeah. What if you expand them to be, which will be x minus 1, there will be 4. Then where is the negative 1, you replace it with j squared. Then it will be x plus j squared. And
why is the j coming? No.
Oh, I squared.
Oh, we're putting the I squared there. So now I've got a question. Because the way you asked me question, now I'm asking you, since I'll take it as if I'm also learning, where is the E coming from? How have you brought the E? You make me understand. The others here, they're also asking, the other guys are asking why you've said that will be equals to E in C. How?
Negative 1 in the identities, negative 1 is equals to E squared. So to simplify it, we put where there is negative 1, we put positive E. So it will be x plus E squared power 4. Yeah, that's how I've done it.
Okay, I like your thinking. You guys, you are studying. I like your thinking. Any other person? So you've given us 3 propositions. The first one you've cancelled it. The second one you've cancelled it also. You are standing with this one, right? Teddy. You are standing with the answer you've given now, right?
Yes.
Okay. Any other person? Any other person? Or we'll just leave it for the assignment. You discuss in groups and then you know. You learn better when you're in groups. Any other for the girls? Because no girl has said anything. No, so far the girls who've said at least. Now I wanted to hear others. Mulenga, what do you say?
I'm still working it out. Yeah.
Okay. Okay. Who else? It's like people now they are disconnecting. Some of them I'm sure they're joining with others for other people's names due to network or running away from questions. So what we're going to do here now, where is this boy? There's one who was almost there. Kaweza, can you go again with your explanation? You are almost there. You are almost there. Kaweza, what did you say?
I said it has already been decomposed because x has the power 1, the highest power as 1. So there's nothing we can do. That 3 isn't the power for x, I think. So we'll just write C minus 1, then 4 of them.
Yes. That's it. The rules, what did we say? It's not its multiplicity, it's what's inside. It's what's inside. I even explained it here. It's not the multiplicity, it's what's inside. So if what you have inside has to the power 2, you have to reduce it to the power 1, because in C we say that a polynomial is only reduced to its simpler form in C only when it has a what? A power of 1. And then in R is when it has a power of 1 and 2, and when it's 2, it's supposed to be what? When it's 2, it's supposed to be, its discriminant must be equals to a negative. Those are the two conditions. So understand your coup. When answering these questions, pass through your notes, check those two small details. They are very important. They are very important. So even here, it will just be the same thing. And then the one who brought the thinking of putting Aisha, no. That is wrong. The thing which you use is you use the degrees of the polynomials which are inside. That's the rule that you use. I hope, Ted, you are okay with that, but I liked your thinking. It shows that you are studying. Even everyone who tried out, those who gave, the girls who tried out, the other guys who tried out, trying is very important. And thank you for trying. And that's why I said the answers were not wrong, but they were right in their own way. In their own way, they were right. But the correct answer is what Keweza had given us. Yeah, I think we can call it a day now. Can call it a day. So I said question 5 and 6 will be part of your assignment. So you can start working it out. And then I said you need to make PDFs. You write your names there in the people who are participating. Everyone must participate. And if you don't participate, if only your friends are doing it, you may think you are lying to me, but you'll be lying to yourself, because it's you who's supposed to benefit. And please don't move to another question. Don't solve with friends to finish, solve to understand. So when I'll be marking as a group. I'll be marking as a group, not as an individual. So when you'll be solving as a group, only move to the next point when everyone has agreed and when everyone has understood what you've done there. Explain to one another. It's not that when someone asks you when you're solving, they don't know. It's just that they want to know. Don't look down on each other. Those who understand, you give you give your opinion, and then in a discussion, give opinions. Whether it's wrong, just try to give. Because if you keep the opinion to yourself, it might be wrong and you will continue with the same thinking. Or it may be right and you may not help others, or you may not make yourself to be convinced that what you are thinking is right. There are many ways you can solve these things, but if we put our heads together, we'll be successful. So I encourage the groups which have been posted to work together. Don't solve to get everything, or you solve to get everything as a group, and don't solve to finish as a person. And yeah, you should all meet. I'm sure you've got places where you can meet, you sit down, you discuss and do the work. I hope we're all clear.
Yes.
So if we're all clear, please make sure each house, I know the number of houses which are there for the guys. I'm sure you're all, how many houses are there, Lawrence, for the guys?
Yeah,
11, 12?
11 apartments altogether.
11. So I'll be expecting 11 PDFs from the boys. From the boys, I'll be expecting 13, because the 5 who are in the city. So I'll be expecting 13 from the boys, and then from the girls, I'll be expecting. From the girls, you guys are 18. The names were 18. So 18. How many? How many? are you going to have? 6 from the girls, right?
Yeah.
Yeah, so from the girls, I'll be expecting 6. Yeah, you all work together. Otherwise, thank you very much for the time. I hope those who are complaining about more examples, I think the first 4, I think this is what you're going to find on polynomials. If you study this, you understand this, wherever you go, you never go wrong. If you go deep into polynomials, you answer more questions. You know, mathematics is a subject of, let me say, mathematics. If you don't practice, you may think you don't know. So practicing is very important. Whether you know something, don't say, no, I know this, I will not touch this. It will cost you. Small details are very important. They change everything. Pay attention to small details. I'm sure in French, Dilax used to tell you that. Small details, pay attention to them because they will cost you. They will cost you. So I said I'll also send something, but after the assignment, when we're done with polynomials, you do the assignment. I'll send you some questions on a certain PDF. It's a very good PDF. It has questions for polynomials and answers, so that you can be solving on your own and you check the answers. Yeah, and some of them in other schools, they use the same PDFs to ask questions, or if you want to revise, even to make TDs, some of them. Yeah, so I'll send it to you guys when you're done with the assignment. Maybe you may find the questions I'll give you be from the assignment, but the questions I'll give you being the assignment will be from the past quarter. But I'm not saying you should go and search for it so that you can copy and paste. But anyway, I'll not remove questions from there. I'll remove questions from somewhere else. Yeah, so that's it. I don't know if there are any questions or anything. Anyone? I'm going to send the answers. Okay, Kennedy, I don't have the notes. I sent it in the group. Oh, Kennedy, I think you're just added from none. I'll send it. I'll send it to you. The notes, I'll send them. Don't worry. And then for the answers, I'll send them. I'll send the whole PDF in the group. I'll send the answers, and then you should pass through them. Where I told you about to my errors there, just do something where I said where it's supposed to be squared, what and what. Just take note. Don't get confused when you see it. I did this, but here what? No, don't get confused there. So, are there any questions before we say bye? Before we say bye to each other? Any other questions?